Okay. Use sigma notation to write the sum. Same type of problem that we just did. Okay. If I'm going to write this sum in sigma notation, I need to know where do I start, where do I stop, and what is the rule that gets me these terms. Okay. We've done a problem similar to this before, but let's look at it. I mean, clearly, what do we have here? We have another fraction. Now, when you look at this fraction, what's changing on the top? Nothing. So we have a 2. This is the first term. This is the second term. This is the third term, right? So since the top's not changing, let's just look at the bottom. They really helped us out here. Everything on the bottom is a power of 3. 3 to the what, though? Well, in the first term, it's a 2. In the second term, it's a 3. In the third term, it's a 4. So how am I getting this number? I'm adding 1 to that number, and that is n. So I have to say n plus 1. Does this make sense to everyone? Okay, so where do we stop? That's the tricky part, right? This is where we stop. We stop when we get that number. So if we stop when we get that number, what that means is, and we've talked about this, this number is the result of plugging a number in, plugging an integer into this. Okay? What integer is it? I don't know, but it's that one. Right? Let's say it's 10. If I plug a 10 here, will I get this? You can guess and check, right? But come on. Let's be honest, students. So we have 2 over 177, 147. Right? Take a look at this equation. We don't have to get too involved. Take a look. We have 2 fractions. Take a look at the setup to this problem. We have 2 fractions. We're saying that this rule creates this term. Right? But since the numerator is always 2, really what I'm looking at is I need the denominator, the 3 to the n plus 1. I need that to equal that. Right? What do we call this? We call this an exponential equation. And how do we solve exponential equations? By isolating the exponential term. Sorry, I don't want you to get confused here. That's n plus 1. I isolate the exponential term, and then I try to write this as a power of 3. Or, if you don't want to do that, take the log of both sides. If I take log base 3 here, this is going to come down. I'd have to take log base 3 over here as well. So I'll have n plus 1 times log base 3 of 3 is equal to log base 3 of this monstrosity. This is equal to 1, so I have n plus 1 equals whatever this is. It's going to be an integer. I'm running out of time on the camera here, but we're going to get an integer here, and then you subtract 1 from that, right? So whatever you get for this, whatever this is, we're saying that that number is what I plugged in to get this term. And so that asterisk value, whatever you got there, that's what goes here. That was the last thing I got. Again, take a look. I'm going to start by plugging in the number 1 here. That would be 3 squared. So 2 over 3 squared. 2 over 3 squared for the first term. If I plug in the number 2, I have 3 to the third power. That's 2 over 3 to the third power. There it is. So this thing is the result of plugging a number in. What number? I just did all of that work to figure out what that number is. So that is the last number that I plug into the sum. Can you do this like through brute force and just plugging in values and guessing and checking? Yes. But use something that we just talked about last chapter. Be a mathematician, be a problem solver.